Hello everyone. I am going to present our project titled Automation of Library Management System using Autonomous Robot. Let me provide an overview of the robot system. Since it takes a lot of work to manually search a book in a library, and if a book is misplaced, it will take more time and effort to find it. We provide library automation for effective book detection and selecting to solve this problem. It is primarily composed of a robotic module and a user module. There is a web page and a user module. The robotic module includes an arm with RFID technology, Zigbee, a color sensor, and a DC motor for picking library books. By creating an autonomous robot to pick up the needed books and place them on a borrower's table, the library administration system is automated in this project. The website was made so that the user may access library books. In order for the robot to locate the required row in the rack and pick the books when the RFID tags are matched, a rack is created with various color tags that are placed in each row. Coming to the objectives, there are four objectives of the robot system. First one, to identify, pick and drop the appropriate book efficiently using a robotic arm. Second one, to design database where all the information about the books and the location will be stored. Third one, to create a web page for users to enter the book details. Fourth one, to intimate the user when the book is available. The proposed system consists of a robotic module and a user module. By providing details about the book that needed to be borrowed or returned, user can communicate with the robotic module using the user module. The option to borrow or return the book is provided on the user module or web page. If the requested input is sent to a robotic module through Zigbee during the borrowing process and the requested book in the library is located, the robot will retrieve it from the rack. The robotic module is made up of a database that contains data on the books in the library and allows it to keep the track of where the book is located. The robot maps the location of the book containing rack after receiving the information, then moves along the pre-planned path to reach the book. The robot then moves along the same path to borrower's table, extends its robotic arm to grab the book, and eventually drops it. The user is given the option of either requesting the physical book or a soft copy of the book if the requested book is not currently in the stock. Once the book has been returned by another user, the user may request a message informing for its availability or digital copy of the book. Additionally, on the website, suggestions for comparable books will be sent to the user. The microcontroller in the suggested system is an Arduino, which is programmed in the Arduino IDE software using embedded C. The user module and the robotic module communicate with one another using Zigbee. Python is used to create web page that can be visited on a computer or a smartphone that allows users to submit book information for either borrowing or returning books. Coming to the methodology, this is the proposed system's block diagram. It consists of a color sensor, a PC, a Zigbee module, RFID module, an Arduino as a microcontroller, a H-bridge DC motor, and a robotic pick and place assembly. As stated, the proposed system consists of a robotic module and a user module. User interacts with the robotic module through the user module by providing details about the book that need to be borrowed or returned. The option to borrow or return the book is provided on the user module or web page. If the requested book is sent to the robotic module through Zigbee during the borrowing process and the requested book is in the library, the robot will retrieve it from the rack. The robotic module is made up of database that contains data on the books in the library and allows it to keep the track of where the book is located. The robot maps the location of the book containing rack after the receiving information and then moves along the pre-planned path to reach the rack. The robot then moves along the same path to the borrower's table and extends its robotic arm to grab the book and eventually drops it. Coming to the flowchart, it is shown in the figure. Entering the book's title and selecting whether to borrow or return it using the user module is the first step in the suggested system. When a user clicks borrow or return button on the web page, the book's availability is checked in the database. If the book is available, the robot activates the issue or collect state and performs the desired actions as illustrated in the flowchart. The user is given an option to the user is given an option to request the book in the event that the book is not available. Simultaneously, similar books that are already available in the library will be recommended on the website. The user will also have an option to order a soft copy of the desired book. Upon request, the user will learn whether the book is still available after another user has returned it. When a user clicks borrow option on the website, he is prompted to enter the book's details and the robot is informed if the book is available. If the user chooses the return option, he will be prompted to enter the book details. If the entered details are accurate, the robot will be informed to fetch the book from the borrower's table and return it back to the rack. This is the design of the robot and the rack. As you can see, the robotic structure consists of a DC motor for providing motion of the robot in the library, a screw rod for the vertical movement of the robotic arm, pick and place clipper to grab the book from the rack and drop it on the borrower's table, and connecting shaft to support the screw rod. Whereas in the rack design, you can see there are different color tags placed on each row. Each color tag is used uniquely to identify the books in the rack. So coming to the results, these are the three figures shown. The first figure is the initial position of the robot, where the robot is waiting for the user's command for the book details. And the second photo, you can see the robot is picking the book from the rack. After the user enters the book details, before reaching the rack, the robot traces the predetermined path to reach the rack. And the third figure, you can see the robot is carrying the book to the borrower's table. Here in figure 4, you can see the user is prompted to enter the credentials to login. Here in figure 5, you can see the user is asked to enter the title of the book to borrow. Figure 6 shows the availability notification on the web page, after which the details of the book is sent to the robotic module using Zigbee module. Figure 7 shows intimating the users about the availability of the book. Thank you.